Right, so welcome to this tutorial, and we are gonna be looking at the following questions, and these will be a series of question on sets, and we make sure that we go step by step and make sure that we solve each and every question. So this first one here reads to say, let E there be the universal set such that E is defined as the set of all x such that x is less than or equal to 13, and E and x is just a whole number. And they're saying let A be equal to the set that is 1, 2, 3, 4, 5, and then B is the set containing the elements 4, 5, 6, and 7. C there you have defined like that, and you have D here, which is also defined there, G like that, and F, the set containing 1, 5, and 4. So now the first question here they're asking us to do is to list. We must list the set E, that is the universal set, and then D and what and G. So listing these out, what are we gonna get? So we have the set E, and the set E, as we can see, is defined as the set of all x such that x is less than or equal to 13, and x is what is a whole number. So whole numbers are just natural numbers, but they include a what? A zero. So these are just natural numbers, but they include what? Zero in them. So that means that we're going to list starting from 0 all the way to what? To 13. Because here they're saying those numbers are less than or equal to 13, meaning 13 is actually part of our set. So meaning here we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. We will have it there, and we close like that. So this here is our set E. Okay, so now after listing set E, we can now what? List set D. So set D has been given by a formula. So you look at here, it's saying set D is the set of all x such that x is in between 1 and 10. So x is in between 1 and 10. And then they're telling us that 1 and 10, you see here, it's strictly less than at this point, strictly less than here. They are also strictly or less than. So this what just means is the endpoints, which is the 1 and the 10, are not part of our set. They are not in what? In the set. So when we list out our elements, we make sure that 1 and 10 will not appear in our set. But then the set x here has been defined by what? By that formula. And x has been defined by the formula that is x is equal to, that is 2k plus 1. And then they're telling us k is just a natural number. So natural numbers, counting numbers, that's starting from 1, 2, 3, all the way going up to what? Infinity, like that. So that means that for us to get our x values here, what do we need to do? We have to start replacing here, starting from 1. So if we replace 1 there where k is, I'm going to have that this 2 by 1 gives me 2 plus that 1. There it's going to give me 3. So this here is the first element that I have in my set. Next, I have to replace what? 2. So here you see replace 2. You're just going to have x will be equal to 2 multiplied by 2 plus 1. And this will be 2 times 2, that is 4 plus 1, and you're going to have what? 5. So you're going to have 5 there. So now you see here that you continue to do this, you're just going to be ending up with odd numbers that are in between what? That are in between 1 and what? 1 and 10, but not including what? Including 1, no what? No 10. So the odd numbers that are in between 1 and 10, that will just 3, 5, and then what's the next one? The next one is going to be 7, and we're going to have what? 9. So these are the odd numbers that are going to be there. So we are still in our interval x, we've listed that way. All right, now let's look at the next set that are telling us to list, and the next set we are listing is the set G. So the set G has been also defined by formula. So you see here it's telling us that a set of all x such that x is in between 1 and what? And 13. 1 and 13. But then where there's 1, they've included less than or equal to. That means that 1 can be part of our set. 1 can be what? Part of our set. But then in our case, in this case, x has been defined by x is equal to what? To 2k. So x is equal to what? To k. That's the formula which they've defined x by. So that means to be getting our values here, and k also, they've said k is just a natural number here. So where k is just a natural number. So it means if I start replacing the natural numbers there, starting from, of course, that is 1, and then making sure that I only get numbers that are going to be in between, that is 1 and 13, but 1 could be there included. But then based on our formula, you see that it won't be part of our set. So if I put 1 there, so I start 1, I just get what? 2. So the first element is what? Is 2. So, and this is why we're saying that 1 there could not be part of a set, because when you replace 1 where k is, you just get 2. So the first value of x is going to be 2. And then you replace the next value, which is 2, and you get this, will give you what? 4. So you get 4. You continue doing that, you're just going to be getting even numbers. So the even numbers that are in between the 1 and 13 are just going to be 2, 4, you have 6 there. So even numbers, in case you've forgotten, numbers that are divisible by what? 2 and do not leave a remainder. So that's an even number. So I list those even numbers. I'm going to have 2, 4, 6, I have 8 there, I have 10, and I have 12. So these here are the numbers that are in between. So I've listed out my sets just like that. Now, next here, they're telling me, okay, yes, we've listed. What's the next thing? They're telling us to find A intersect, and then you have C union G complement. So they're telling us to find that there. Okay, so this is how we're going to do that. So you have A intersection C, then union G what? Complement. So this C here, in the exponent of the G is just what? Standing for complement. And a complement of a set, these are elements that are not in that set but sit in the universal set. Okay, what do I mean by this? So if I say G complement, so G complement is going to contain all elements that are not in G, but they are in the what? Universal set. So in our case, our universal set is this one here. That's our universal set. So what we are saying is elements that will not be in this set G, but they are in the what? In this universal set there. So now you look at the set G. The set G is listing even numbers that are in between 1 and 13. So now numbers that are not going to be sitting in this what? In this set, but are in the universal set, that is 0. It's not in G, but it is in the universal set. 1, not in G, but in the universal set. Then you see I can get 3 there, 5, 7, I have 9, I'm going to have 11, and I have what? I have 13. So this here is my what? Is my G complement. So that's how you'd get a complement, the complement of what? Of a set. That's how you'd get the complement what? Of a set. And then you see here, it's saying C, so this is C union G. So what union? Union. So the symbol in between here, that is there standing for union. So union just means elements that are in the set, either in one set or the other, or in both of them. So in our case, what this means, C union G complement means elements that are either in C, or they're in G complement, or they're in both of the sets. So that's what that means. So in short, what you're going to do is you're just combining elements that are in what? C and in what? G complement, and bringing them what? Together. Okay, so that's what you would do. So now C here has already what? Been given. So what I'm gonna do is I'll say my C. So C, I list down my C. My C is just there you have it as 5. So you have C as 5, 6, 7, 8, 9. And then union your G, which is just here, your G complement, I mean. So that's 0, 1, 3, 5, 7, 9, 11, and 13. So this is what you have there. Okay, so now we bring everything together. So it's just going to join these elements all together. So you have 1 there, you have 2, you have 3, After 3, there's 5, so 5. And then here you have 6, so 6 you bring there. And then you have 7, and then we have 8, so 8 to come here. And then we have 9, 11, and 13. So this here is the set that is C union G complement, this part here. But well, we are not done yet, because what the question is telling us is to intersect this finding which we have found here with the set what? The set A. Intersect. What does that mean to intersect? So this symbol here you see here, that looks like an N. This symbol here stands for intersection. So intersection. So you can tell the difference. The other one is union. The other one is intersection. So intersection means elements that are common in both of the sets. Elements that are common in both of the sets. So our listing here is going to be, so my set A has been given there as elements that's 1, 2, 3, 4, and 5. So in short, what we are doing, we are saying we are getting the set A that is 1, 2, 3, 4, 5, like that, and then intersecting with what? C union G complement, which is this side here on the left. Okay, so what are we going to end up with? So this here is just going to be equal to, so now you look at the elements, what are common in both of these sets? When I intersect them, what are common? So I see there's 1 here, there's 1 there, so I can write 1. It's common in both. Then there is 3 there. There is also a 3 the other side, which is here, so I can write 3 there. There's a 5 here, and there's a 5 there, so I can write what? 5 there. So these here are the only elements that are what? That are common. So this is how you would what? You would get your answer like this. So that's how you would what? You would find your answer. Well, another way of thinking about it is, but we will land to the same conclusion is, let me erase this. Okay, so another way of just thinking about it is, so this value which we got, this set down here, this here is our C union G complement. So now C union G complement, and then what does okay, so C union what? Union G complement. All right, maybe let's not go that way. We would complicate things. Let's do the next one where I'll explain that concept on the next one. So on the next one, we are having that they're telling us we need now to find that is A set difference with what? With B. A set difference with B. So what this means by definition, it means a set of OX such that X is a member of the set A and X is not a member of what? The set B. So this is what it means. X is in A, but X is not in B. X is in A, but X is not in B. That's what this here represents. We call it the set difference. So that there is the set difference. So how do we get these elements? So we just need our set A and our set B, and we find out set difference, which we already have. Set A is there. So what's our set A? That's 1, 2, 3, 4, and 5. And then my set B is just going to be equal to, that is 4, 5, 6, and what? 7. So what I'm saying here, what we are saying when it comes to a set difference of A and B, we are just saying, okay, let us consider elements that are in A. Yes, of course, they're in A, but they are not in B. So what elements? Okay, so those elements are going to be, so first of all, I see 1. 1 is in A, but when I look at B, 1 is not in B. So meaning that is going to be in that set. And then I look at 2. So 2 is in A, but it's not in what? In B. I look at 3. 3 is in A, but it's not in what? In B. Then 4 and 5 are in what? Are in B, so there's no need to list them there. So you get this here. That is the what? The set difference. So that's how you would get it. But then, if you wanted to think about it another way of thinking about it is saying A intersect. So what this set difference A, the set difference of A and B there means is just A intersect what? B complement. So in other cases, you'd want to find what? The B complement first and just intersect it with what? With A. So what did we say complement is? We said elements that are not in that set, but will sit in the universal set. So B complement, so if I was to list, you see here we still get the same answer. My B complement is going to be, so my B listed here, there's 4, 5, 6, 7. So I get those elements that are not in what? That are not in B, but are in what? This universal set here. And those elements are a lot. That is 0, you have 1, 2, you have 3 there, and then you from 4, 5, what? You skip these and then you just go there. You're going to have what? You have 8 there, you have 9, you have 10, you have 11, and then you have 12, and you have 13. So these here, these are what is your B complement. Okay, now finding the B complement like this, now we have to just intersect it with what? This is A intersect B complement. So just find the common elements. Now, what are common in both of the sets? This complement in green and what? This part here. So again, those elements that we ticked out, the 1, the 2, and the 3 are the ones that are common. And you see that you still get what? This answer which we found. So that would be an alternative way of what? Of thinking about it. But even this, the set difference is just so direct, where you're saying this here is just you saying that the elements that are in X, but they are not in what? They're not in B. Those are the ones that you're going to what? You're going to choose. Well, let's do the next one. We see how we're going to get this one. So for the next question, there you have, they're telling us A intersect B like that, and then the set difference of what? Of C. So that means we have to first find what? A intersect what? Intersect B. So A intersect B is going to be, so this here I list down. So this here I'm looking at elements that are common in A and in B. So what is my A? So my A, I know it's 1, 2, 3, 4, and 5. And then intersect this with what? With B. So my B here is going to be, that is 4, 5, 6, and what? And 7. So now I look at the elements that are common in both of these sets. So you have 4 there and you have 4 there. You have 5 there and you have 5 there. So the intersection of this is just going to be 4 and what? 4 and 5. So 4 and 5 are in the intersection. Now, they're saying this, the A intersect B, then the set difference of what? Of C. So in short, what that is going to be, so A, this A intersect B, then set difference with C is just going to mean elements that are what? That are in the A intersect B, but they are not in what? They're not in C. Elements that are what? That are in A intersect B, but they're not in C. So let me then write this like this. So this here is going to be, so A intersect B, we have that is 4, comma what? Comma 5, like that. And then you have set C. The set C is listed as 5. That's 5, 6, 7, 8, and what? And 9. Now, let's look at the elements that are in this A intersect B, but they are not in what? They are not there in, they're not there in that set, they're not there in that set C. Yeah, they're not there in that what? In that set C. So elements that are in A intersect B, they're there, but they're not in what? They're not in C. So you look at that, you see there's only what? There's only 4. So there's only 4 there. So then this here is just going to give us that our answer is going to be what? 4. So A intersect B and then set difference of C, this here gives us what? Gives us 4. So these are the elements that are sitting in A intersect B, but they are not in what? But they're not in C. So that's what this means. All right, let's do the last one here. So last there we have, that is F, and then set difference, you have A intersect D and then complement. So here what do? We have A intersect D. So what is A intersect? So there's A intersect D complement. But before we do that, we need to find A intersect what? D. You know, math is so fun. You just have to do it step by step. So A intersect D, that's what you get first. So what is your A? So my A, so my D is there. My A, I have been listing, which is just 1, 2, 3, 4, and 5. So now intersect, which elements are common between these, and there? So there's 3 is also there. So 3 there. And then you have 5 there, and then You have also 5 there. So 5 is common. So these here are the two elements that are common in both of the sets. Now, saying the complement of this. So the complement, we said they are elements that are not in this set here, but will sit in the universal set. So now I look at what those elements are, and they are the majority of the elements. So every other element in this universal set here, which we have, apart from 3 and what? And 5 are going to be in the what? In the complement. So now let me list. We are listing now A intersect D complement. So every element that is not here but is in the universal set, that is 0, 1, 2, 3, we skip, we go 4, 5, we skip, we go 6, 7, 8, 9, 10, 11, 12, and 13. So these here are going to be what? These are the elements that are in A intersect D complement. The last part here is you're getting the set difference that is of F and this part here, which we just got. So now, what is my F? So my F has been given, that is 1, 5, and what? 9, like that. Set difference with what? This whole thing here. Okay, so what is that going to give me? So let me write it here since I already know that we're taking set difference. So I can write it here. That is set difference F, that is 1, 5, and 9, like that. So now here it's what we are getting is elements that are in F, but they are not in what? In A intersect D, what? Intersect D complements. They are not in A intersect what? D complement. So what elements are those going to be? Okay, let's just make sure we did this right. So elements that are what? That are insert what? Insert F, but they're not in this A intersect what? Intersect D. Okay. This here is just going to be, you will have that saying we remove those elements that are in there. So those elements that are not in what? That are in here, but they're not in what? They're not in that second part. So now what elements are those going to be? So 1 is there, 1 is there, so that won't be in our set. So when you look at 5, 5 is there, but 5 is not in A intersect what? Intersect D complement. So 5 is going to be in that set. And then you have so 9 is there and 9 is there. So meaning 9 won't be part of our set. So this here 5 is just the only element that is going to be what? To be in our set. Okay, so that's how we find that one. Right, let's move on to the next question. All right, so the next question here reads to say, let E be given by, that is a set of OX such that X is an integer, and that integer is in between 0 and 21. In between 0 and what? And 21. So now they are telling us A is equal to, then A has been given by this set, and that set has defined X by a formula, and they're saying X is less than 20, and then K is a member of what? The natural numbers. And then there we have B being given like that, and then you have C also being given that way. So here they're telling us to draw what? Draw a Venn diagram. So we must draw a what? A Venn diagram. So how are we going to what? To represent this? So if we are to write out, so we have to write out our universal set. So universal set here is just going to be those elements starting from 0, and then because 0, they've indicated 0 is part of our set. There's less than or equal to there, so 0 is going to be part of our set. And then they're integers. So that's 0, 1, 2, okay. And all the way now, we'll be going up to what? 20, 21. So you could list them. They're going to be lots like that. So all those what? Integers that are from 0 to what? To 21, part of our set. Then now let's also list this set A. So set A has been given as X is equal to 2K, and then you have minus what? Minus X. So how are you going to then do this? They're saying k here is a natural number. So we start replacing natural numbers here. That is starting from 1, and then so I've indicated, okay, so it has to be like it's 2k minus 2, yes. And then, so k here, I replace what? Start replacing, that's 1. And we need to get values of x that will be less than what? Less than 20. So it's strictly less than 20, meaning that 20 cannot be part of what? Of our set. So if we put 1 here, we'll see you get 1 there minus 2. And this just gives you 2 minus 2, which is 0. So our first element there in the set, what? In the set A is what? 0. You do the same, you put 2 there, minus 2, that's 4 minus 2, which gives you 2. So you get 2 there. So now you see that you just be getting even numbers here. We'll just continue to get even numbers that are less than what? That are less than 20. So meaning that's 0, 2, 4, and then you have 6, you have 8 there, you're going to have 10, 12, 14, 16, and 18. Okay, so the next number here would be 20, but 20 we're being told is not part of our set. So we end it here like that. The rest of the other sets have already been listed out for us. So they're telling us, first of all, to draw a Venn diagram. So let's draw that Venn diagram. Okay, so our Venn diagram, let's draw it here. It's going to be like that, there. Okay, and then we have how many sets? You have 1, 2, 3, and then you have the universal set. So universal set goes there. So this here is our universal set. Then we draw our 3 sets. That is, you have the first one like that, and then you have another one there, and then you have another one there like that. So okay, so these are the sets that we're going to have. So that is there, you have set A, and you have set B, and you have what? Set C, like that. Okay, so here now, we can now list or put what? Our sets there. So first of all, we have to find what is common in all of them. That is A, intersect what? Intersect B, intersect C. So that is in between there. So you look at these are numbers. So you'll be looking at numbers that are in all of the three, the 3 sets. So what numbers are those going to be? So in all the 3 sets, okay, let's look at all those numbers. So you look at A and B, and then what? C, like that. So here in B, we have 1, 2, and there you have 1, 2, but here there's no 1 in the what? In set A, there's no 1. The 2 is there, but there's no 2 in B. So we skip that one, and then we go, which other one are common? So when you look, you see that 8 is there, and then we have 8 there, and then we have what? 8 there. So 8 is common in all of the sets. So this here is going to be, I'll list this as there, and then 8. So 8 is there, and then which one can I list next? So there you have 19, 20, like that, and you see that, okay, that's the what? Those are the only elements that are common. Then you move on now to look at, okay, which ones are common in A and what? And in B. Which ones are common? Which ones are both in A and what? And B. So A intersect B, which ones are those going to be? So this is my A, and that's my B. So I look at what are common in both of these 2 sets here. So 1, okay, it's not there. You look at, no, 19, it's not there. 20, it's not there. So you see that the only element that is common between A and B is the 8, which we've already what? Written out. And between just A and B, there is nothing that is common apart from what? Apart from 8. Okay, then next you want to list those that are in both elements that are both in what? A intersect what? That are both in A and in C. Both in A and in C. So this is our A, our C is there. So what are those elements? So you look at there, you see 2, and 2 is what? Is there. So in A and C, you have what? You have 2. So I'll put 2 there, like that. So 2, and then what other element you have? So you have 6 there. So I put what? I'll put 6 there. So 6 there. Okay, and then what other element you have? So that is the what? That is that. Those are all the what? The elements. So 2, 6, and then 8 there. So these are the ones that are common between A and what? And C. Then you go, you say A and what? I mean B and what? And C. So B there and your what? Your C. You see, look at what are common. So there's one there and there's one there. So here you say 1 is going to be there. And then what else do you have? Okay, so that is all. Apart from that, 1 there, and then 8, we've already put it there. 19, no, it's not common. It's not in both of the sets. 20 is not both. Okay, so that's all. That is what that is common. The next, the remaining elements, you're going to list them here. So those that have remained in A. So when I look at the set A, what elements have remained? So 2 is gone. 6 is what has been removed, and 8 has been removed. What has remained? What has remained? I have 0. I have what? I have 4. Then I have 10. 10 there. Then I have 12. Then I have 14. Then I have what? I have 16. Then I have 18. So these are what common in, these are what has remained in the set A. And then I now go to what has remained in the set what? In the set B. So the set B is there. So 1 I have removed, 3 have, I mean 8 has been removed. So what has remained? You have 3 there, and you have 19, and you have what? You have 20. Okay, now you go to see what has remained. So 1 has been removed. Then you have that 2 has been removed. 6 also what has been removed. And then 8 also has what been removed. So you remain with 9 there, and then 11, and then you have what? You have 15. Okay, so this is what has been removed. Then now you are going to list those that have remained in the universal set. Now you look at the universal set, which is this set here. Which ones have what? Have been what? Have remained. So out of all these that we've put here, we now identify which ones what remain. So 0 has been removed. I know that 1 has been removed, 2 has been removed, 3 has been removed, 4 has been removed. And then what do we have? 5. So check, has 5 been removed? 5, 5, 5. No, 5 has not been removed. So 5 is going to go there. So 5 is what? Is outside there. Okay, so 5 has not been what? Removed. Then you go 6 has been removed. Then what next one? 7. So 7 has not been removed. So 7, we can list it there. So 7 has not been removed. Then 8 has been removed out of there. 8, then 9 has been what? Has been removed. Then 10. 10 also has been what? Has been removed. 10 has been removed. It's there. Then you have 12. Check, 12 has been removed. 13. So 13, check sets. Has 13 been removed? No. So 13, you're going to list 13 there. So 13 has not been what? Removed. So 13, 14 is there. 15, yes, 15 has been removed. It's there. 15, 16, 17. No, 17 has not been removed. So 17 is going to be there. 18, 18 has been removed. 19, 19 also has been what? Been removed. Then you have 20, 20 also has what? Has been removed there. Okay, then that leaves us with what? The last number, which is 21. So 21 is going to be there also. So 21 will be outside. So these are the elements that do not sit in any of what? In any of those sets. So now we have listed them that way. Now we can find what they want us to what? To find using this Venn diagram. So let us find the sets here that they are asking for. So the first one, they are telling us to list that is A complement intersect what? B complement. So first of all, you're going to say, what is my A complement? So what is this A complement? So A complement, we said these are elements that so A complement will consist of elements that are not in A but are in the universal what? In the universal set. Not in A but are in the what? Universal set. So in short, all elements that are not in this set A but they're outside A, those will be what? To be the A complement. So if I list those elements, so outside A, all these here that are outside A, and they're the ones that I'm going to list there. So you see you have 1 here is not in what? Is not in A. You have 2 there, or 2 is in A. You have 3 there, so 3 there is not in A, 3, and then I want to list them in order. You have 5 there, and then you have 7, you have which one else do we have? We have 7, you have 9, you have 11, there you have 11, then you have 13, you have after 13, what we have 15 there, 15, then we have 15, then we have so 3, 9, 17 there, and then we have what? 19, and then what other value? We have 21. Okay, so those numbers should be 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so these here are going to be in what? In C complement, and then B complement. So B complement, you're listing now those that are not in B, but are what? But are in the what? In the universal set, or sit outside what? That sit outside the set B. So set B only has the elements that is 1, 8, 3, 19, and 20, meaning everything outside there is going to be part of what? Part of B complement, which is, if you start listing, that is 0 there, you have 2, you have 4, so you have 4 there, and then what other elements do you have? 4, okay, so 4, then we have 6, 5 here also, I forgot 5, so we have 5 there, so 4, 5, and then we have 6, then we have 7, then we have so 8, no, then we have 9, and then we have 10, we have what we have 11, 12, 13, 14, 15, then we have what? We have 16, 17, 18, 19, no? Then we have what? 20, no, 20 is there, also 20, then we have, so that would be what? 21. Yeah, so we have these, so that would be 0, 2, and then 4, 5, all the way, then we remove just 19 and what? So the elements that we should remove from the universal set, that is, we just have to remove 1, 1, 3, 3, and 1, 3, 19, and 20. Okay, so this here is going to be in the complement. Then they're saying A intersect what? B complement. So now A intersect B complement, you're looking at elements that are common in these sets that are both in set A and B. So A intersect B complement. So I look at which sets are each elements are appearing in both sets. So when I start looking here, comparing, so you have 5 there, you also have 5 there. So it's common, so 5 there. And then you have what element? 7 there, you have 7 there. You have 9 there, you have 9 there. Okay. And then you have what? You have 11 there, you have 11 there, like that. Then we have 13 there, we also have what? 13 there. 13, and then we have what do we have next? We have 15 here, we also have 15, so 15 is there. Then you have 17 there, 17 is there, 17 there. And then 19, no, then you have what? 21 there, and also what? 21. So this here is what is going to be what? That is what is going to be in our A intersect what? B complement. That is 5, 7, 9, 11, 13, 15, and what? And 17. Okay, so this is how we would what? We get that. All right, let's move on then to do the next one. So here, next we have So our next question there is this part, that is A union B, and then intersect what? Intersect C. So A union B, we said A union B, you're looking at elements that are in what? Both the set A or B, elements that are in both, elements that are in set A or they're in set B, or they're in what? Both of what? Of those two sets. So let's first list down A union what? Union B. So A union B. So I get, what I'm getting is the set A and the set B, and bringing all the elements together. So you see 0 is there, 1 from B, and then what do we have? We have 2, we have 3, we have 4, then do we have 5 here? No. Then we have 6, okay. 7, do we have 7? No. Then we have what? We have 8. Then do we have 9? Do we have 9? No. Then do we have 10? Yes, we have 10. 11, do we have 11? No. Then we have what? We have 12. Yes, 12 is there. 13, do we have 13? No. 14, yes, 14 is there in the set here. That is the set A. 14, okay, do we have, so we are what, counting at 15? No. 16, yes, we have it there in the set A. 16, then we have 17, do we have 17? So 17, no. Do we have 18? Yes, 18. Do we have 19? 19 is there on the other side. And then you have 20. Yes, 20. Okay, 21, just like there, 21 is not going to be there. So this is where we what? End. So you have 0, 2, 4, 3, all the way up to what? Up to 20, those elements that have been listed. So those are what are going to be in what? In our A. Those are A what? A union B. That's 0, 1, 2, 3, 4. Then when you reach here, when you reach 4, going to this side, they are just what? They'll be even until up to the number what? 19, and then you list 20 there. Okay, so this is A union B. And then intersect C. So our set C, which we have is, that is 1, 2, 6, 8, 9, 11, and what? 15. So this is our set what? Our set C. Okay, then now they're telling us A intersect what? A union B intersect C. So A union B we've listed there, and then intersect C. So what is that going to give us now? So you look at elements that are common in both sets. So you have 1 there, you have 1 there. So I list 1 there. And then you have 2 there, 2 is also there. So 2 is common in both. And then you have what? 6 here, you also have 6 there. So 6 is what? Is common in both. You have 8 there, you also have 8 there, like that, it's common. And then, do we have any other? No, we do not have any what? Other element that is common. So we close it here. So that there is our A union B intersect what? C. All right. So next here. Okay, so the next one, you have A, then say difference with, that is B union what? C. So here, I'm going to list what? I'm going to first list out B. Let's find B union what? C. So B union C, you're looking at combining elements that are in B and in what? And in C. So that is going to be number 1. There's 1 there. There's 2 there. Okay. There's 3 in B. Is there 4? No, 4 is not here. 5, no. 6, yes, 6 is there in what I said, C. 6, and then you have, what do we have? 6, 7, no. 8, yes. And then 9, yes. 10, no. 11, yes. And then 11, 12, no. 13, no. 14, no. 15, 15 is there in the set C, so 15. 16, no. Then 17, no. 18, no. 19, yes. So 19 is there. So you have 19 there, and then you have 20. So 20 there is what is there. Okay, so these are all elements that are what? That are in both, combining the elements that are in both A, that are in both B and what? That are in both B and C. Okay, so now we've combined those elements, and then now what we want is with this here, the set difference, that is A. So if I list the set A, we said that is, we had found this to be at the beginning, we found this to be 0, that's 0, 2, 4, 6, then you have 8, 10, 12, 14, then 16, and what? 18. So this here, then now we're getting the set difference with what? This set. So this set, which is B union what? Union C. So now what does that mean? That means that we are getting elements that are in A, but they are not in B. Elements that are in A, but they are not in what? In B. That's what that means. Elements should be in A, but are not in B. So if I look here, I'm going to have those elements that are in A, but they are not in what? They're not in B. So if I look at 0, so 0 is in A, so this here is the set A, but it's not in this set A union what? B. So I'm going to have 0 there. Then you have what element? So 2 is there, 2 is there. So you go 4. So 4 is in A, but it's not in this union of B and what? And C. So 4 there. Okay, what element follows here? You have, so here, 6, 6 is there, 8, 8 is there. Okay, so 10, 10 is not in what? In this part, so 10 goes there. Then you go 12, so 12 will be there. Then 14 is there, but it's not in this what set. Then 16, 16 is also there, but not in that set. And then you have what? You have 18. So this here I then close. So this here is going to be my set difference, that is of A, set difference of the union of B and what? And C. All right, now let's do the last part. So last part here is just telling us to find that is A union B complement. So A union what? B complement, of which we earlier found what A union B is. So we found A union B. So I'm going to just list down that set, which is A union what? Union B. So A union B is just combining all elements that are in A and in what? B. That is 0, that is 1, 2, 3, 4, 6, 8. Then you have 10, 12, 14. Then you have 16, 18, and then you have 19 and what? 20. So these are the elements that are in what? A union B. But what complement means, the complement of that set just means elements that are not in what? A union B. So we want elements now that are not in this set which we've listed, but they're in the what? In the universal set. So in short, elements that are going to be outside what? So let me shade that region. So it's going to be in this region here. So outside the union of those two. So where this red shade here is, that's where those elements have to be in. So these are the elements that are what? That are not in the what? In the union of what? Of A and what? Of A and B. So these are the elements that are not there. So that means A union B complement is just going to be, that set is going to contain, so now I list those elements. So those elements here, you see that we're just going to have 5. So 5 there. I can see 5 there, 17. So everything that is under the red there is what I'm going to list. 7, I mean. And then you have what? You have, I'm listing it in ascending order, so 9. And then you have 11 there. And then 11, after 11, we have 13, then 15, then we have what? 17, and then we have 21. Okay, so this here is what I would get. So this is how I would list out my set. All right, let's move on to looking at another concept here. So next concept that we're looking at power set. So they're telling us to find the power set of the following questions here. So now one thing that we first must know is what a power set is. So the power set is just a set that contains all possible subset of what a given set. So we denote this power set as P of a set A, for example. So what this here is going to contain is all possible subsets that can be what? That can be in the set what? In the set A. So now you can also ask, what is a subset? So a subset, we say that, so we say A is a subset indicating like this is a subset of B. That is if every element that is in A is also in what? In B. If every element that is in A is also in what? In B, then we say A is a subset of B. So in short, if A can be contained in B, then we say what? We say A is a subset of B. So now what this power set is showing us all possible subset of what? Of the given set what? The given set P. So if we have a set, if we have a set A and this set has elements that is 1, 2, maybe up to what? Up to a value n. So these are elements that we can actually count. That is 1, 2, 3. So they are countable in short. So to get the power set, first of all, we also have to understand the term of cardinality. So cardinality is just the number of elements in what? In a given set. So the number of elements in a what? In a given set. So the number of elements, we just count those elements that are in that set. That is for a finite set. You can count elements that's 1, 2. So in this case, we have 1, 2, up to what? Up to n. So we have what? N elements, since we don't what? We don't know what n is. So we have n elements like that. So in a given set, maybe if A was 1, 2, 3, like that, it means we have how many elements? 1, 2, 3. So we have what? The cardinality, which we denote A with two lines like that, which is just representing cardinality in this case, is this here, the cardinality, which is the number of what? The number of elements in that set is going to be what? To be 3. So you put your what? You put your 3 there. Okay, so now how is this going to help us? So this concept of the cardinality helps us to find out also the cardinality of what? Of the power set. That is, how many power sets, or how many subsets will what this power set contain? How many subsets will that power set contain? So I write the modulus like that. And then this here is given by the formula that is 2 to the power what? To the power n. So this is how I know how many what? How many subsets are there. So in this case, for example, this A here, which we gave, where we found n to be what? To be 3. So it means I have 2 to the power 3. So this here then means what? I'm going to have 2 to the power 3 is 8. So it means that the power set should have what? Should have 8 what? 8 sets in it, 8 subsets in it. So that's how this we are going to get that. So now to get the power set of what? Of A in this case, so you have to list or at least those subsets. So in short, a power set is a set containing what? Other sets. So, and then one thing that we must know is that the set itself is going to be what? A subset of the power set. So the set itself is going to be what? Contained in the what? In the power set. And then also the what? The empty set, which we denote like this to mean the empty set. The empty set is a subset of every what? Set. The empty set is a subset of every set. So just when starting to list, meaning you know that you have what? You have the empty set, you can list it there. So the empty set like that. And then, so this empty set, before we even go further, so the way we've denoted it, this empty set is equivalent to us just writing what? A set like that. So these curly brackets here are what we are using to what? To denote our sets, or to what? To list our sets. So now here, this here is going to be, now you're going to what? List, we're saying those subsets are what? Are 8. So you have the next set here, you just what? List the set containing one element, and that element in this case is what? Is 1. So you list 1 like that, and then you list the next one as 2, and then you list the next one as what? As 3. So now here we have 1, 2, 3, 4. So we've listed 4 what? 4 sets. So how many more are remaining? We're remaining with 4. So now the next one means we are going to what? To pair up. So you have 1 and 2. So you have the set that will have 1 and 2, and then you have the set that is going to contain 1 and what? And 3. Okay, and then you have the set that is going to contain what? Contain 2 and what? 2 and 3. So now we've listed those elements there. Then we said even the set itself is going to be what? To be contained there. So it's going to be 1, 2, and what? And 3. So if we count these, you have 1, 2, 3, 4, 5, 6, 7, 8. So here I close like that. So so those 8 are the what? Are the subsets of what? Of the set A. So hence we found this P of A, this here which we've listed, is the power set of what? Of the set A. So that's how you would what? You would find that. Now let us then go on and find the what? The answers for this question that's here. Okay, so first of all, they're telling us that A is equal to what? To the empty set, because it has no elements here. So that is the empty set. So now it means that here, this we said is equivalent to us writing what? Like that. So that's the empty what? The empty set. So the power set of the empty set is just what? The empty set. So the power set of the empty set A is going to be what? The set containing the what? The empty set. Since the empty set is a subset what? Of itself. So you're going to have, it's going to be a set containing the empty set like that. So this here is the power set of what? The power set of A. And then we have B here. So B is listed as, that is 1 and what? And 2. So the cardinalities 1 and 2. How many elements do you have there? You have when we talk of the cardinality of B, you have two what? Two elements there. So the power set of what? Of B, when you talk of the cardinality of the power set of B, it's going to be 2 to the power n, which is to the power 2. And then this is 2 squared. So 2 squared is what? Is 4. So you get 4 there. Okay, so now it means that our what? Our power set is going to contain what? 4 sets. So that power set contains 4 sets. So we say the power set of what? Of B is going to be equal to, so you list, first of all, you list the what? The empty set. So the empty set is going to be part of that set. Then you list the set containing one of the elements, that is 1, the other one, 2. And then you have 1, 2, 3. So you have 3. The last one, it means the set what? The set itself. That is 1, comma what? Comma 2, like that. So this here is the power set of what? Of B. Okay, so even in the first case where we're finding the what? The power set of the empty set, when it comes to finding the cardinality, it's the same. You just say the cardinality of the power set of A is going to be equal to, so 2 to the power, what? How many elements are there? Since it's the empty set, so by definition, it has no elements. So meaning there's 0 elements. Any number raised to the power what? To the power 0 is 1. So 1. Hence, there in this power set, we only had what? One set that was listed, which is the empty set. Okay, so we do part 3. So part 3 here is just containing a set of what? Vowels. So it's saying X such that X is a what? Is a vowel of the English alphabet. So the English alphabet, that those vowels are, you have R, A, E, O, and what? U. So like that. So these here are the vowels of the English what? The English alphabet. So now, it means here, let's first find the what? The cardinality of this power set. We see how many elements are there. So 2 to the power, so now we count those elements, 1, 2, 3, 4, 5. So it will be to the power 5. So this here is going to be what? It's going to be equal to 32. So it means you have 32 sets that are going to what? To sit there. So 32 subsets that are going to be what? To be there. Those are a lot. So listing them is going to be tedious. So if you start, meaning you have to start list the empty sets, list A, E, I, O, and U alone, and then you start pairing them. That is A and E, A and I, A and O, A and U, just like that. And then you go these two like that, and then so you pair them, they become 2, 2. Then you go in the 3s, then you go in the 4s, and then just like that until you what? You finish. So those would be what? Your elements, where we want to list them out because those are a lot, but you can try them. Okay, so let's then move on to the next part. So the next part here is telling us to say you have A intersect B. So you have A is a subset of B. Then they're telling us then simplify each of the following sets. So if A is a subset of B, we're just saying A is contained in what? In B. So if I write the set like this, so you have there. So you have the set B there, this is the set B outside, and then you have the set what? The set A like that. So A can be what? Contained in B. That's what the subset there is telling us. So what is that going to be? So you see here, they're telling us to find A intersect B, what? Complement. A intersect B complement. So how is this going to be? So A intersect B, what is A intersect B going to be? You're looking at elements that are common in both A and B. So those elements that will be common in both A and B are just going to be here. So those elements that are common in both A and B are just going to be what? To be those elements that are in the set what? That are in the set A. So it means that A intersect B is just equal to the set what? To the set A. And if it's equal to the set A, then if we replace here where A intersect B is, you have this here is going to be what? A, and then the complement there. So this just means what? A, what? Complement. So this A intersect B simplifies to what? To A complement. Okay, let's now do the next one. So next there you have A union what? B complement. You have A and then union B complement there. Okay, so what is this here going to be? So I'm going to list this. So now you have A union what? B complement. So now first you find what? B complement. What is this B complement? So B complement, you're looking at elements that are not in B but are sitting in the what? Universal set. So those are elements that are outside there. They're not in B but they are there outside. Okay. And then you have what? You have this, they're saying union what? Union A. So what is A? So A is this part here, like that. So A is that part there. So now, is it possible for us to then what? Simplify this further on? No, because this is in its simplest form. So you just write A union what? Union B complement like that. So this is what you're going to what you're going to get. Because that part there, yes, we know that remaining part here, which is outside, is the what? Is the universal set like that. It's outside what? It's B what? B complement. And then you have that this part here is in the middle part is what? Is that middle part is the set what? The set A. So that's the set what? The set A. So there might be some elements in here that are in B, which we what? We don't know. So they might be put in there. So now when we come to bringing every element that are in A and B together, we can't write this in what? Any other simplest form apart from the way it's been what? Written like this. Okay, let's now do um, that last one there. You have A intersect A complement and then union what? Union A. So you have A intersect A complement union what? Union A. So how are we going to write this one? So I can write this as A union and then you have B intersect A complement. So what this here is, you can according to sets. So here we can distribute, we can use the distributive what? Laws. So you can distribute this A union across this set. So you have A union B like that. And then in between there you have intersection. And then you have A union what? B. Then you have what? Complements there. So A union B what? Complement. So let us see how that is going to be graphically. So that is going to be, okay, so I draw, so I have my set there, and then like that. So this here outside B, and then you have what? You have A there. So A, we know is this part. And then A complement is everything outside A, which is there outside A, everything outside A. But then it means that every part of this Venn diagram is going to be shaded. And that is going to mean that this here is just going to be the what? The universal set. So this will be E there. And then you have A union B intersect the universal set. So whenever you intersect any set with the universal set, you get that set. So you're going to have this will be A union what? Union B. So this part here just simplifies to what? To A union B. Okay, so that's what We get there. So you have A what? You have A union what? Union B. That is going to be what? It's going to be there. So now, what is A union B? So when you look at A union B, you're looking at elements that are in both A and what? And B. So those elements that are in both A and B are just what? So let me erase this. So the elements that are in both A and B, combining those elements. So you have B there outside, and then you have A there. So elements that are in both A and B, so it will be this here. So that's my A union B. But my A union B is just the set what? The set B. So this simplifies to what? To B. So our final answer there is just going to be equal to B. Right, so that's how you would solve this question. Okay, so next, they're telling us if A and B are disjoint subsets of the universal what? Set. Simplify each of the following. So what they mean is that if they are disjoint subsets, it means A intersect B is what? Is empty. There are no common elements between A and B. So in a Venn diagram, that's going to look like, so you have this here like that, and then I'll have that is, and so then there's no intersection. So it will not intersect that way. So you have another what will be here. So there's no part which will overlap there. There'll be no overlapping. So you have A and you have what? B there. So this now here is going to be, they're telling us now if A and B are disjoint subsets, simplify each of the following. So what is A intersect B? They are disjoint, so there is no intersection. So we've already found it. By definition, that's what it means of disjoint sets. Okay, and then now, what is A intersect what? Intersect B complement. So A intersect B complement. So you have A. Now, let's find what? The B complement. So B complement is all those elements that are outside what? That are outside the set B, but are in the universal set. So this is the universal set here. So outside B, these there are going to be what? To be the elements that are going to be there. So that is what this here is B what? B complement. So B complement just simplifies to what? To this other part here. This the set A and what? And the other remaining part of the universal set. Then they're telling you that you should intersect this with set A. So it's A intersect B complement. So find the common what? Common part. So with what? The set A. So now here it means we just shade the set what? Set A like that. So a set A like that. That's what we're going to shade. So now from what we've shaded here, intersection, these lines here have crisscrossed. It means that they will have what? The common elements between the what? Between the two. So hence this A intersect B complement will just simplify to the set what? To the set A. So that there's going to be equal to the set A. Okay. Then here next we have A complement union B complement. So what we just use what? The Demorgan's laws. So the Demorgan's laws here just state that if you have A intersect B complement, this here is the same as saying that is A intersect what? B, and I put the complement there outside. So now my A intersect B complement is what? The empty set, which is here. So the empty set, and then I say the what? The complement of the empty set. So the complement of the empty set, a set of having nothing. If we take elements that are not in that set, they're not in that set. So meaning they have to be contained somewhere. So, and that somewhere is what? The universal what? The universal set. So meaning that this here, the complement just gives us the universal set E. And just like that, you would have what? You would have simplified. Okay, so then we move on to the following. So the following say express each of the following in its simplest form. So here we are going to use the laws of what? Of sets which we've learned. So that is the distributive laws, associative laws. We will use what? We use Demorgan's laws in order to be able to what? To simplify these sets. So the first one is A union B, and then you have what? Intersection A, and then union B what? Complements there. So here we're going to use what? We see that you have A union B and then you have A union B. It means they are distributed there. We can factor out that A union B. like that. So in the first part, you remain with what? B, and then there's intersection here. So intersection will be there. Then A union B, okay, and then B complement. So B complement will come there. Okay, so now A intersect B complement. So if I draw my Venn diagram, I have the set B. This is my universal set, and I have the set B. So set the B is here. B complement is what? Is outside, everything outside there. So now here, that what elements are going to be common? Will not be any what elements that are common between B and what? B complement. So whenever you just see B intersect B complement, or any set intersect its complement, it's going to give you the empty set. So this is going to be empty. And then you have A union what? B. So whenever you say A union an empty set, it's always going to be what? That set itself. So this here is going to be the set A. So this will give us set A like that. Okay. Let's then simplify the next one. So next here you have the set that is X intersect Y and then complement union, and then you have X set difference Y, and then you have their complement outside. So I can distribute this complement. So when I distribute, so always when you distribute, if you have A complement and then you're getting its complement, this here is going to give you the set A. Okay, so this is what it's going to give us here. So we are going to have that when we distribute there, here because of that complement to go, you have just X intersect what? Y remain. And then this sign here, by the Demorgan's laws, it's going to flip, it's going to change. So from union to change to what? Intersection. So this here becomes intersection. And then you have X, say difference, and then the complement is going to go what? To go there. So there you have X intersect what? Intersect Y, then intersect. So here inside, you can write this as X intersect what? Intersect Y, and then the complement will go there. And then you have a complement outside there. So it means we can distribute this complement also inside. So you have X intersect Y, then intersect, then this is going to give you C complement, then union, the sign changes now to union, and then you have what? This here, the Y, the complement goes, just remain with what? With Y, like that. So now, how do we simplify this? So let's see how it looks on what? On a Venn diagram. So this here is going to be, if I have two sets like that, this is X, that is Y, and complement. So X complement everything that is outside what? That is outside the set what? The set X, but is in the universal set. So that is going to be this here. So that is my X complement. There is my X complement. Then they're saying this X complement union what? Union what? Union Y. So I just bring or include Y there, elements also that I want, that I know Y. So that would include this part also, like that. So let me shade now this. Okay, so this here would be the A. Okay, let me. So this here would be the X complement union what? Union Y. This is how it would look. Then now they're telling us that we are intersecting that with what? A intersect what? Y. But now where is A intersect Y? So A intersect Y is just here in between, like that. That is A intersect Y. So we're intersecting this whole thing with that part. So we're looking at which elements are going to be what? Common with this middle part and those part. So we see that these lines, the blue lines and the red lines, have crisscrossed what? On the middle. So it means that what you just remain with in your set is just going to be that part there. And that part there is X intersect what? Y. So this here just simplifies to X intersect what? Y, like that. So this here is our answer for that one. Okay. All right. So then the next one, you have B complement and then intersect. You have A union what? Union B. So how are we going to do this? You can distribute here. We distribute. We say B complement intersect A. So that's B complement intersect A. like that, and then you have union here, and then you have B complement, then intersect what? Intersect B. Okay, so now here we know we said B complement intersect B, or is this here is going to give you the empty set. And then there you remain with A intersect what? B complement union. So here the union of the two will just give you what? This here is just going to give you A intersect what? B complement, like that. Okay, so like that, that's what you're going to what? You're going to get. So if we draw this on a Venn diagram, how this would look is, so you have your set A, so set A there, and set what? Set B, like that. So this here is going to be, so B complement everything outside what? B, but is in the universal set. So those are going to be those elements like that. Like that. So that is my what? B complement. So that's B complement. And then intersect what? A. So A, the set A is this one here. So where do they intersect? They intersect at this part. So you have that, your set, if you were to just shade your A intersect what? B complement, you have this part here, that they are like that in your what? In your Venn diagram, where A is there, B is there, and that's the universal set. This is how it would what? It would look like that if you are to shade it. But then can we simplify this any further? No, so we just leave it there. Okay. Okay, so next we have that is A complement union, and then you have A intersect B complement, and then complement there. So now you can distribute that complement inside here. So that would be A complement complement, just gives us A. So that sign changes from union to intersection. And then here you just have A intersect B complement, and the complement will go there. This will be equal to, that is A intersect, and then you can distribute the intersection there, you get A complement, that sign changes to what? Union, and then there you get what? B, like that. So this then is going to be, I can distribute the A intersection here, the A intersection, that's by distributive laws, and I'll just have A intersection A complement, like that, and then there's union there. So union, then there I'll have A intersection what? Intersection B. So A intersection B complement, this here is going to be empty, then union A intersect what? B. This just gives us A intersect B, like that. So this here is what as a set simplifies to. Okay, so the next question that we have is here. So that question reads, in each of the following Venn diagrams, shade the region representing. So we must shade the region that is representing A intersect, that is A set difference of what? Of C, and of C what? Complement. So in these Venn diagrams, we must shade this set here. So I can simplify this by writing that is B intersect, then I say A intersection C what? Complement, then the complement. You can distribute that complement such that I have B, then intersect, there I'll have A complement, then what? Union, that sign changes by Demorgan's laws, union to this one there, you get what? A C. Okay, so this is what we are going to what we are going to have. So we can first handle this part. So what is A complement union C? A complement what? Union C. So in this first diagram here, when you look at, you have A and C there. So your complement, the complement of what? Of the complement of A is going to be outside what? Everything that is outside A. So this will be like this. So though that here is going to be my like that. That there is going to be my A complement. And then we are saying union what? Union C. It means include even the elements that are what? That are in C. So that is going to be also this part here, including the whole set what? The whole set C, like that. So this here in blue, the whole thing in blue is A union A complement union what? Union C. Then they're telling us find B intersect what? Intersect. So B intersect A complement union C. So this here is going to be, you just intersect what? Intersect B. So intersecting B, you have this part here. So this is the set what? The set B. You shade the set B all in all parts of what? The set B. Okay, and then now you look at where did the lines crisscross. So the lines crisscrossed, so it crisscrossed everywhere apart from, and that is this part here, like that, and then there, like that. So this part here is where they what? They had crisscrossed. So this is where we're going to what? To shade, and that is what our answer is going to be. So this here is going to, so if we are to shade, we have this here like that. Okay, so this is how our set is going to what? To be. Apart from that part there, that's how you're going to what? To shade. Okay, so that's how you would what? You would see this one on this one. Now, they want us to do the same on the what? On the other Venn, what? The Venn diagram, this other one. So we first find also A complement union C. So you look at your A complement, everything that is outside what? Outside the set A, but is in the universal set, that is going to be your A complement. So what are those? What is that region here? So everything outside, I'll shade there. I will not touch A, I will not shade anywhere near the set what? The set A, but I'll shade outside there, like that. So that there is our A complement. So this here is our A complement. Okay, so now there is our A complement, and they're telling us union what? Union C. So union C just means even those elements that are in C, let's bring them, let's put them together also. So meaning I'll shade what? This part here of C, if you look at where C is ending, it's ending there. So I'll shade also that part of what? That part of C there, like that. Okay, so this here in red is what is our what? Our A complement union C. Now we must find, we intersect it with the set what? The set B. So intersect set B. So it means I shade the whole set B. Okay, so I shade in this direction, like that, like that, like that, there, all the way, that is set B, there, like that. So this here, you see that this is what? The intersection. So now this part where the lines have crisscrossed, that is what? The intersection. So where the lines have what? Have crisscrossed. So that is everywhere. So apart from, so you see this part here, like that is our what? Is our outline, that there, coming like that, all the way up to here, like that. So this here is how it's going to what? It's going to be, and then the whole set there. So to shade that, you're going to have, this is going to be, okay, let me just erase this here. Okay, so our set is then going to just be, so shading that, you have this here. So like that, that's what you're going to get. Then this part, this green part is not there. So you remove this part here. Okay. So like that, this is how our set is going to be. Okay, so they are like that. You shade here. Okay, so that's how you shade this one. Let's now do the next one. So we are using the same Venn diagram. So the next one is telling us you have B intersect and then A union C complement. So what is your A union C? So A union C without the complement, just A union C, that is looking at elements that are common, that are, I mean, elements that are in either A or B, or they're in both of what? Both of the sets. So though that region could be this here. That is our, this here could be your A what? Union C. This is what is your A union C is. Now we are looking at the complement, meaning everything outside this region here, which was shaded. So meaning that our A union C complement, because now the brought in complement, is going to be everything outside the union. So that is going to be, so I shade this here like that. Okay, so you have this here. Okay, so this here is our A union what? Union B. Then they're saying this A union B intersected with what? With C. So I'll shade the whole what? With B. So I'll shade the whole what? The whole set B that way and just check, okay, where are the lines crisscrossing? So the lines have crisscrossed there, which is just going to look like first. So where the lines were crisscrossing was just this part here. So this part there. So that there is what is this A intersect U, A intersect U union C complement. So that's what that would be. Okay, the next we do it here. So you have A union C complement. So that is going to be outside here. Okay, so this here is going to be our A union what? C complement. And then we have to intersect this now with what? With the set B. So I shade the whole set B and just check, oh, where have those lines crisscrossed? So there is my set B that I've shaded. And then where have my lines crisscrossed? So the lines have crossed or crisscrossed here to there and just that outer region there. So let me then just show you this. So there we just get that our answer is this region here, like that. So like that. So this here is our answer for that question. Okay, so this is how you shade. Okay, so let us now look at this following question. So the question reads, people consume tobacco using 3 different what methods. So the first one is they smoke. Other one is they sniff or they what? They chew tobacco. Then they're telling us a survey was conducted on 70 tobacco what? Consumers. And the results came out as what? As follows. So they're saying 70 here tobacco what? Consumers took part in what? In this survey. And then they are telling us now that 56 smoked. So smoked there will represent smoked by SM. So 56 smoked. And then 56 what? Sniffed. So SN is for sniffed. So 56 sniffed. And then you have those that chewed CH, those are 50. And then they're telling us that 48 smoked and what? And sniffed, meaning those are going to fall into what? Into an intersection. So that is S, those that smoked and what? Sniffed. So SM intersect what? SN here is going to just give us 40 what? 48. And then those that smoked and chewed, so smoked intersection chewing, those were just what? 42. And then you have those that sniffed and chewed. So SN intersect what? The chewed. So that is going to be what? 44. So now determine the number of people who used what? All the three what? All the 3 methods. So they want us to determine all those that use the 3 methods, meaning those that smoked, that sniffed, and that also what? Chewed. They were doing all the what? All the 3. So here what we're going to use, we just use the inclusion what? Exclusion formula, which is just given as. So if we had 2 sets, let's say we had 2 sets A and B, that would be given as A union what? Union B, and then you get them the what absolute value. So this here, what you're getting the numbers of what of people in that set. So, and as we said, the cardinality of what of the people in what in that set. So A like that, then plus B, and then minus A intersect what? Intersect B. So this here would be the what for two sets. Then if we had three sets, like which is our case, A union B union C, like that, that cardinality is going to be equal to, you say A, the cardinality of A plus that of B, then that of C, and then minus, so you subtract the intersections, those intersections between the two sets. That is, you're going to have A intersect what? B, and then minus A what? Intersect what? Intersect C. So the cardinality of the intersections, you have to what? Subtract them out. So the reason why we're subtracting is because if you list the set A and then you add it to the set B, so it means that those elements that are common, or the number which is what? Which is representing A and B, would have already been counted for. So you have to what? Remove it there. And then you remove the other one also for what? For A and C. And then you remove also, so for what? For that is B and what? B and C. So you're going to remove there, B intersect C. Okay, so now if you remove, then it means that you would have removed what? The common one which is there. So you have to what? You have to add for both the cardinality of all the what? I mean, all the three sets. That is A intersect B intersect what? C, like that. So you add them. So this here is what we're going to use in order to find or to determine the number of people who used all the three sets. So here they're telling us 70 tobacco consumers, like the survey, those that took part, they were what? They are 70. So meaning if we combine those that smoked, that sniffed, and those that were chewing, all together they were 70. So we put what? 70 there. So you have 70, and then you look at those that what? Those that were smoking. So those that smoked were what? 60, 50, 56. Those that sniffed were also 50 what? 6. And those that chewed were 50. Then minus those that smoked and sniffed were what? 48. Then minus those that what? Smoked and chewed were 42. And then those that smoked and what? Those that sniffed and chewed were 44. So minus 44. And then the last one here is supposed to be those that what? That smoked, those that sniffed, and those that chewed. So those that did or used all the three what? The three methods. In our case, that's what we are finding. So we represent that by what? By X. So then the next thing here that we ought to do is just what? Just to add now. So you add this. So I add 56 plus 56 plus the 50, I get 162. So this here gives me 162. And then I add that 48 plus 42 plus 44, that gives me 132. 134, then plus X there. So I subtract the 162 minus the 134, that gives me 28. So I get 70 minus 28 plus what? X. So X is going to be equal to 70. The additive inverse of 28 is negative 28. So it goes to the other side, it becomes negative 28. And this here, I subtract 70 minus 28, then I get what? 42. So 42 people are the what? Are the number of people that what? Who used all the three what? All the three methods. So here, 42 are the ones that what? That used all the three methods. Now, how would this then look in a what? In a Venn diagram? So that's the next thing now that we're going to do. We're going to draw a Venn diagram. Okay, like that. So you have like that there, and then there, like that. And then you have another what? Another set there. So those that smoked would come here. Those that sniffed, put them there. Those that chewed, put them there. So 42, we found that 42 used all the three methods. So 42 is going to be there. So you put your 42 there. Now you tend to those that what? Smoked and sniffed. Those that smoked and sniffed, they were 48. So it means that between this part here, there, it means that we must only have what? 48 people, because they're the ones that smoked and sniffed. So this here is just going to be, so we're going to have, so if the 42 did all the three, it means we have to remove. So we say 48 minus what? The 42. So 48 minus 42 just give us 6. So 6, so what does this 6 mean? So 6, these are just those that smoked and sniffed only and did not use any other method. They smoked and sniffed only. And then we moved on to smoke and chew. So it's here. So those that smoked and chew, have 42 there. So 42 minus the 42 which we have, which is those that are in the intersection of all the three, you see this gives us 0. So we have 0 we have none, in short, that smoked and chewed only. So then we go to those that smoked and those that sniffed and chewed. So sniffed and chewed, you have 44. So 44 minus the 42, you get what? You get 2. So you get 2 there. So when you see here, we add them, we get 44. So 44 are those that are falling in what? Those that sniffed and chewed. But those that sniff and chewed only, we are just what? 2. Okay. And then now you consider what? The remaining set. So here we had 56. So 56 are the ones that are the ones that smoked. So it means when I add all the elements, all the numbers that are in this smoked set here, those that smoked, you're supposed to have what? 56. So that means if we add, so 66 plus what? 6 plus 42, there you have 6 plus 42, you get 48. So 48, then you subtract from what? The 56. So you have 56 minus 48. So 56 minus what? 48, you get what? You get 8. So 8, this 8 represents what? Those that were what? Or those that smoked only. So the only method that these 8 used was what? The smoking only. Such that you see that when I add all these, I add the 8, the 4, the 42. When I add everything there, I'm going to get what? I'm going to get the 56. So that there, the 56 is those that use the method of what? Of smoking. And then I go to what? To sniffing. So sniffing, I add, that is the 6. So you add the 6 plus the 42, then plus that 2 there, then you get what? You get 50. So you get 50 here. So you add 6, 42, and 2, you get 50. Then I subtract from those that use the method of what? Sniffing. That is the 56. So you get 56 minus 50, which gives us 6. So 6 are the ones that sniffed only. So they just used only one method, which is sniffing. And then the other one here, they're talking of what? Those that chewed. So those that chewed, we are going to add 42 plus 40, plus this 2, which gives us 44. So 44, then we subtract minus what? The 50. So 50 minus 44, which will give us what? Will give us 6. So that now, this 6 here represents those that chewed only. So now after plotting and putting everything here, all these numbers, when we add them together, we must get what? The total number of people that took part in in this survey. So that is going to be 8. If I add 8 plus 6 plus 42 plus 2 plus 6 plus 6, I get 70. And here you can check that just by punching those numbers in a calculator, and you see you get what? You get 70. So this is how you'd plot it on a Venn diagram. Well, they didn't even want us to use that to do any of that, but then we just needed to show that. Okay, so remember, they just told us to determine those that participated in all the three, and we found that 42 using the inclusion exclusion formula. Okay, now let's do the next one. So the next one is telling us in a class of 100 students. So in a class of 100 students, so 100 students, they are saying 60 like what? 60 like math. So all the students here, in short, then the total number of students. So I said total T is what? Is 100. And then those that like what? Mathematics. So M, I'll say mathematics for M, and those are what? 60. And those that like economics, those that like what? Economics are 40. So E are 40. And then you have those that like what? Demography. So demography, they are what? 40, 45. Then in addition, they're telling us those that like both mathematics and economics, those that like both mathematics and economics. So M intersection E. So they like both. So M intersection E is just what? 20. So 20 like both mathematics and economics. Then they're saying 25 like economics and demography. So E intersect D. They are what? 25. And then they're telling us that 30 like both mathematics and demography. So M intersect D. Those are like mathematics and demography. That is 30. And then they're saying 15 like all the three courses. So 15. So M intersect D intersect E. They are what? 15. These like all the three courses. The first one says draw a Venn diagram to represent what? The information, which we have just from learning how to do. So we can easily draw like that and there. Okay. And you have, so you draw your three sets there, have set one like that. And then you have another one, which is there like that. You draw. And then you have the last set there like that. So I'm going to label to say this here is mathematics, that is economics, and that there is what? Demography. So now those that like all the three are what? 15. So 15 there, they like all three what? All three subjects. That's mathematics, economics, and what? Demography. Then now, let us find those that like mathematics and economics only. They like mathematics and what? Economics only. They don't like what? Demography at all. So here they've told us those that like mathematics and economics are 20. So 20 like mathematics and economics. But this 20 includes even those that what? That like demography. But what we want those that like what? Mathematics what? And the economics only. So what do? We will remove those that like demography, such that we remain with those that like what? Mathematics and what? And economics. So we say 20 there minus what? Those that also like what? Demography in there, the 15. So you remain with what? With 5. So here the 5 is going to go there. So that 5 represents those that what? Like mathematics and economics only. Then we go to those that like what? Those that like economics and what? And demography. Those that like economics and demography, which is this part here. They're telling us it's 25. So 25, we remove those 15, we will get what? 10. And then we go mathematics and demography. They're telling us it's 30. 30, we remove the 15, which are these here. Then we'll have what? We will have 15. So this 15 represents those that like mathematics and demography only. They don't like anything to do with economics. Okay, so that's how this will be. Now let us find those that like what? Those that like mathematics only, those that like economics only, and those that like demography only. So how are we gonna do that? So those that like mathematics, so they've told us those that like mathematics should be 60. That set should add up to what? 60. So now to find them, we are going to say 60 is going to be equal to, you have 5 plus, so the 5 like mathematics and economics only, the 15 like all the three, and then you have what there? The another 15 which like mathematics and demography. But then we have X here, which is M to that part, where those just like mathematics only. So this is how you're going to what? To get. So you add those there, you're going to have 15. So 15 plus 15, that's 30, plus the 5 gives you 35. So you get 60. 35 can come the other side like that. You get X equal to X. X is going to be equal to, so 60 minus what? 35, which gives me 25. So 25, which I put here, this 25 like mathematics only. Then I go to the next one here. So I add 10 plus 15 plus what? The 5 there, which gives me 30. So 10 plus 15 plus what? Plus 5 there gives me what? 30. So then I look at those for economics. They are what? 40. So the 40 minus the 30 here will give me 10. So the 10 here are going to be those that like economics only. So I do the same next. I add the 15 there, and the 10. So 15 plus 15, that is 30. 30 plus the 10 gives me 40. So 40, then I want to get those that like demography only. So 45, out of those that like demography, the ones that like demography, they are 45. But I want those that like demography only. So those that like other things, I will remove them. So there are how many in total? We added 15 plus 15 plus the 10, I get 40. So when I subtract, I get 5. So the 5, this 5 like demography only. So now to get here, I can also get the number of people that don't like any of these three. So any of them, because that's possible. There will be people that will not like any of the subjects that they're taking, but they would still take them. I don't know why. But then, so let's add these numbers here. We have 25. When we add 25 plus 5 plus 15 plus 15 plus 10, then plus 5, then plus 10 again. So I get 85. So when I add all the numbers here, I just get 85. So let me erase here. So when I add all those numbers, I just get 85. So I get 85. So 85, at least these 85 took what? A response that they like at least, this 85 like at least one what? One subject. The 85 like at least one subject. So out of the 100, those that don't like any, so I have to subtract 100 minus 85, you get what? So 100 minus the 85 just gives us 15. So this 15 don't like any. So I'm going to put them what? Outside here. So this 15 don't like what? Don't like any of the what? Any of the three courses. So now they are telling us we've put our what information in Venn diagram. So check the first one, and then they're telling us find the number of students who like exactly one course. So those that like one course only, one course what only. So this makes our work easy because we've put this on what? On a Venn diagram. So what are those going to be? So 25 here, they like mathematics only. Those 10, they are like what? Like economics only. Those 5 like what? Demography only. So to find the number of students who like exactly one subject, one course, I'm just going to add 25 plus the 10 plus the 5. So this here is going to give me what? So 25 plus the 10 plus the 5 gives me 40. So 40, these are students who what? These are students who like exactly one course. And then the next one is find the number of students who like neither economics nor what? Demography. Find the students who like neither what? Economics nor demography. So you want to find those that don't like what? They don't like demography. They don't like what? They don't like economics. They neither like demography, they neither like what? Economics. So that means so economics, so if we say economics like that, union what? Union demography. This here, what this means, economics union demography, this here will be the number of students that what? That like demography, that like either demography or what? Or economics. And then if I say the complement of this will include what? Those that don't like either demography nor what? No economics. Those that like neither demography nor what? No economics. So this is what it's going to mean. So again, just to back up, if we say A, E union D, just E union D, it means those that like either economics or demography. But if I take the complement, what I'm saying is these like neither what? Demography nor what? No economics. So now in this diagram, which ones are those going to be? So the complement there is just going to be this here outside, like that. Everything, I'm not shading the union, or I'm not shading E and what? And D, but I get everything that is outside there. So now you look at the numbers that are sitting here. You have 25 and 15. So 25 plus the 15. This here gives us what? this here is going to give us 40. So the 40, like neither economics nor demography. Okay, so that's how you'd find this one. Okay, let's go to another one. So another one says here, a survey was conducted on 80 snack consumers and the following information was obtained. So 62 eat what? Eat chips. So total number which we are conducting here for is what? 80. And then the information that was obtained is that 62. So 62 eat what? Eat chips. That is, we do not see H. Then 55. 55 drink what? Soda. So this drink soda, like that. And then you have 48 drink what? Eat candy. So this eat candy, the 58. So CA, like that. So in addition, they're telling us that 40 eat chips and what? And drink soda. So chips intersection soda, this here is going to be 40. And then they're saying 35 eat chips and candy. So chips intersection what? Candy, this here is going to be 35. And then they're saying 42 drink soda and what? Eat candy. So 42 drink soda, so soda, and they eat what? They eat candy, which is CA. So this here is what? 42. Then they're telling us find the number of customers who eat all the three. So yet again here we are going to what? We're going to use the inclusion exclusion formula, where we said the total, those that eat all of those that either eat the chips, the candy, or the soda are what? 80. So in short, what we're getting is 80 here is the total, and then you get what? The individual ones, as we learned earlier, that is 62. Then you add plus 55 plus the 48, and then you subtract those that take the two, that take any of the two. So you're going to say minus what? 40 minus 40, then minus 35 minus 42. Then plus you what? The number now that we want is those that take the 3. Those that take the 3. Those that take the 3, we don't know, that is X. So don't confuse the number. So X here is representing those that take the 3, whilst the 80 is telling us the total number of what? People that, or consumers that took part in the what? In the survey. Okay, so this is what we get. So now you get 80, then you add these numbers here, you're going to have, that's 62, then plus 55, plus 48, so you get 165. And then minus, so you say 40 minus 35 minus what? Minus 42. And that there is giving us 117, then plus X. So I say 165 minus the 117, which is just going to give me what? 48 plus X. And this here is going to be X is equal to 80 minus what? 48. So this will be 80 minus 48, which is X is just going to be equal to what? 32. So 32 here, this 32, like all the three what? All the three snacks. So we found that one. Now they're telling us the number of consumers taking what? 2 snacks. We must find the number of consumers taking exactly two snacks. So it's going to be easy to just draw a Venn diagram like that and then put your sets there. So you have a set here, and then you have another set there, and then you have another set there, like that. So you're going to have this here for chips, that there for soda, that there for what? For candy. So those that take all the 3, they are 32. I put them there in the what? In the middle, the 32. And then I want now those that take chips and what? And soda. Now I want those that take chips and soda only. They're the ones that will fall here. So I look at chips and soda, there's 40. So I say 40 minus the 32. Here I get what? 8. So the 8 just take what? take chips and soda what? And soda only. And then I go to this one, that is chips and what? Candy, there's 34. So 35 I mean, so 35 minus 32, I get what? I get 3. So 3 will be there. And then I move on to soda and candy, there's 42. So 42 minus 32, that gives me 10. So 10 will take what? These take soda and candy only. Now, yes, we could fill up our Venn diagram, but there's no use in this case because the next question just tells us the number of customers taking exactly two snacks, taking exactly 2 snacks. And these here, which we are just from finding in blue, we have found that 8 take chips and soda what? Only, and they don't take the other what? Snack, which is candy. Here we found 3 takes chips and what? Candy. They don't take what? Soda. 10 take soda and candy, and they don't take what? Chips. So meaning it suffices just to add 8 plus what? 3 plus 10. And these are the ones that are going to what? These are the ones that fall in that aspect that those that like what? Those that like exactly 2 what? 2 snacks. Those that like exactly 2 snacks. So when we add 3 plus 8 plus 3, that is going to give you 13. So 8 plus 3 gives us 13. And then you have, okay, so we said 8 plus 3, that gives you 11, then plus 10. That's going to give you what? 21. So this gives you 11, then 21. So when you add this here, give you 21. So 21 here, our answer is 21, are those that like exactly 2 snacks. Okay, next we have saying let R be the universal set. So R is the universal set, and they're telling us rewrite each of the following in set beta notation. So recall set beta notation is given in a general form where you have X, you have this curly bracket like this, and then you have X there, then you have this symbol such that, then you have X maybe less than number 8, and we say X is what? Is a member of the real what? Real numbers. So it can be like this. Sometimes you can even start X is a member of, so say the real numbers such that X is what? Less than 8. Okay, so maybe like this. So what this bracket here that there stands for, when you're reading, you're just saying this here is the set of. So the set of, like that, that's what that means. And then here X would mean the set of OX. So this is the set of OX. That line there is such that. So this line or these dots here will also mean what? Such that. So such that, and then here now you have your what? You have your condition here. So your condition is that X is less than what? 8. So this symbol, of course, we know is for less than. So less than what? Less than 8. And then X is what? Is a member of what? The real number. So this here tells us where what? X belongs. So it tells us the what? The domain. It tells us the domain. Where does X what? Belong? So X is a real number, or it tells us what type of number X is. So you have it that way. So, or you can have it in this way where you start saying first where X is a what? A real number such that X is less than what? 8. It would be the same way. Okay, so now let us write these here as what? Let us write them in set beta notation. So in set beta notation, you're going to have, you have your set A is equal to, so negative, there 5 all the way to 3. So one thing that we must note here is when you have brackets like this, open brackets, what it means is that, for example, here, negative 5, it means negative 5 is not part of our set interval. There, the 3, negative 3 is what? Not part of our set interval. That's when you have the open brackets. When you have closed brackets like this, you have a closed bracket. So it means if you have 4, 7 there, it means 4 is actually part of the what? The set. And here the what? The 7 is also part of what? Part of the set. and they're telling us they are real numbers. So what this here represents, it represents real numbers that are in between 4 and what, and 7. So real numbers, there are a lot of numbers that are there. So because real numbers uh, consist of natural numbers, it consists of integers, it consists of rational numbers, it consists of what, irrational numbers, like that. Those are what, real numbers. So there are a lot there. So just between even 0 and 1, there are infinitely many what, real numbers. We cannot even count them. If it's these that are here in between 4 and 7, there are so many numbers here that we cannot count them, because every number that has a point. So 4.1, 4.2, 4.3, 4.0001, 4.0002, all those numbers are going to be what, are going to be part of there. So there will be what, a lot of numbers. Hence we just resort to using these intervals to represent those numbers here. Now, let us go on and write them as, we write them as set in what, in set beta notation after discussing that. So this here is just going to be, this will be A is going to be equal to the set of OX such that X is what, they've told us that let A be the universal set here be real numbers. So it means everywhere we're getting our numbers from is what, is the real numbers. So X is what, a member of the real numbers. Then such that what, here they're saying that X is in between negative what, negative 5 and 3. So you say that it's in between negative 5 and what, and 3. Then you observe here that I have strictly put less than symbols. So that means that negative 5 and negative and 3 there are not part of my set. Why have we said so? Because they have open brackets there. That's why we say so. Okay, the next B. So B there is going to be set of OX. So all of them here are real numbers, such that now what interval does it fall in? So it's going to be 4 there, X, and then less than, equal to what? To 7. Why? Because here you see B is defined as 4 there, there's an open bracket, but where 7 is, there's a closed bracket. So it means 7 is actually part of what? Part of that set, or part of that interval. So you have to include the less than or equal to sign there. And then you have B, C. So C is going to be X such that R, and then you have, it's in between, that is 0, less than or equal to X, less than or equal to what? To 4, like that. And then the other one, you have D is going to be equal to set of OX such that X is a member of the real. So set of OX, where X is a member of the real numbers, such that X is defined to be between negative 2 less than or equal to, because there's a closed bracket where D is, and then X there in between, less than, because there's an open bracket where 6 is, and I put my 6 there. So this is how I would use the set beta notation in order to find those results. Okay, next here, we are now moving on to looking at what? Number lines. So they're telling us let R be the universal set. So R is the what? Universal set that we are working with. So in interval notation, you denote R like that, the set of real numbers to be from negative infinity to what? Positive infinity, like that. So when it comes to the infinity symbol, you do not put closed brackets, because infinity is not a fixed point. Numbers continue to go, they continue to increase. We don't know what number infinity is, so we cannot put what? A closed bracket there. So we always put open brackets when it comes to what? The infinity symbol. Okay, so now that is there our what? Our universal what? Our universal set. So now after establishing that, that's our universal set, we have the set A. So the set A has been given by A is equal to, so now this is what we call interval notation. We are not listing. So remember, there were those finite sets where we could just list them to say, okay, this set has 1, 2, 3, 4. This set has 1, 5, 6, and 8. But now in this case, we have a lot of numbers, so we can't list them. So what we do is we denote them using what? Intervals. So A is from negative 7 to what? To 3 and then closed. So all real numbers that are in between that interval there are what? Are the numbers in the set A. B is from 0 to what? To 8. And then you have C. So C is saying X such that X is less than or equal to 10 and X is a real number. So the real number is less than 10. Less than 10. So you have those starting from negative infinity, whatever that point, whatever number that could be, all the way to what? To 10. And then there's less than or equal to, meaning here it has to be closed where 10 is. So that's how you would write that set here, because they've given you in set beta notation, but we've written it now in interval what? Interval notation. Then next is find each of the following sets and hence illustrate the answer on the number line. So they're telling us to find A intersect what? C complement and illustrate it on the number line. So A intersect C what? Complement. Okay, so what is this going to be? So now you look at first, what is your C complement? C complement everything outside C but is in the universal set. So now here, what are those going to be? So you have that this here is actually even easier to watch to see on a number line. So if we say we draw a number line like that, so you're going from negative infinity to infinity that way. So this here is going to be, so our set C. So first I'll plot the set C, which then I find its complement. So the set C here is just from 10 to what? To negative infinity. So here it's closed and I just write by indicating an arrow like that. So this will be my C. So now my complement, so this arrow means it's also going towards the negative what? Direction, like that. And then now my complement is going to be everything outside here but is in the universal set. So it means if 10 here, 10 is in the set C, it means that that 10 will not be in the complement. So it will be outside that C. So in the complement, you have it's going to be open and it will go that way. So this in green is my set what? My set C complement. So my C complement is just going to be from 10 like that to positive infinity. That's my C complement. Okay, so I erase here. That's my C complement. And then they're saying intersect that with what? With A. A, it's A intersect C complement. So now, what is my A? So I also plot my A here. So my A is that there is -7, and then we say my 3 is there like that. So my A is going to be at negative what? -7, it's open. So you open like that. And then you put an arrow, and then you go all the way to what? To 3. 3, it's what? It's closed. So this here is how your set A is. And then my set C complement, I'll write it so that it's going to be from there going this way. Then now you take the intersection. What is the intersection? So look at what is common in these two sets now that we've put. So now you see there's no part where they are overlapping here. So it means that here they do not have anything in common. Hence, the A intersect C complement is just going to be the what? The empty set. It's going to be the what? The empty set. Hence, there's no even need to illustrate even on what? On a Venn or the number line, because it's what? It's empty. We found that it's empty. Okay, now let's move on to the next here. So the next is you have B, set difference of B and what? And A. Set difference of B and A. Okay, so how is that going to be? So it's good. You can think about this as B intersect what? A complement. B intersect A complement. So in short, you can just find your what? Your A complement first. So my A complement is everything that is not in A, but is outside A, which means it's in the universal set. So the universal set is, of course, the set of real numbers in our case. So my A is this here. So let me sketch there that you're able to see it. So my A is from -7 to what? To 3. So there it's open and there it's closed. So it means the complement of this is going to be, since this -7 is not in A because it's open there, it means it's going to be in the complement. So in the complement, it will be closed when I shade here, and it's going all the way to negative infinity. There, since 3 is in A, meaning it can't be in what? In a complement. So it will be open there for the complement, and then it goes there. So this here in blue, this is my A what complement? That's A complement. Okay, so I erase this here like that. So that there in blue is my A complement. And then they're just intersecting it with what? With B. So B is from 0 to 8. So 0 to 8. Let me plot now B. 0 to 8. So that's 0, and I'll say my 8 is here. So that is going to be, so it's open at 0, and it's open at what? At 8, like that. Then they're just asking me, what's the intersection then? What are those elements that are common in both of these sets? So you have this part and that part there. They are intersecting these parts. These here have common elements. Now, yes, they have common elements, but then here you see where there's A complement. It's open here at 3. It's open at 3. So it means that point at 3, it will not intersect, meaning it will be open. It will be open at 3. So it will be open at 3 like that. And then here at 8 also it's open. It's open in this other set, which is what? Which is the set B. It's open there. So meaning even if it's in A complement, because it's open here, that point 8 will not intersect. So it means that point 8 like that will be what? Open at 8. So meaning this B intersect A complement, which is just the set difference of A and B, is going to be equal to 3, 8. 3, 8. So now that's 3, 8. Writing it or drawing that on a vein, on a number line, that is just going to be, so there, negative infinity to infinity. So I say my 3 is there, and I have my 8 there. So it's open here, it's open there. So this here is just your what? Your set. Yeah, this set here, which they're telling us to find. Okay, let's do the next. So next you have A intersect, then B union C complement. So you can find this first here, which is your B intersect C what? Complement. So our C complement, we already found out our C complement is 10 to what? That there. And then union B. So union means you're bringing everything together. Those two sets, you're bringing them together. So let me draw them that you're able to see. So negative 8, negative infinity, and then infinity there. So B is 0 there, and then 8. Then let's say you have 10 there, like that. So this is open there, and then it's open there. That's my B. And then my C complement, it is open here and then going that way, like that. So this here brought together is what is making up B union C complement. So this in green here, that is B union C complement. Now they're telling me, oh, intersect that with what? With A. So my A is from negative 7. So I write negative 7 there, 2, 3. So I write my 3 there. So this here is going to be negative 7. It's open at negative 7, and then all the way to B, to 3, then it's closed at 3, like that. So now they're telling me what are the common what elements here? Because if I say A intersect with this part, which is the green part, what is common in both of the sets? So these parts here and that part there is what is going to be common. These numbers that are going to be falling here in between 0 and what? And 3. So now, what is this going to be? So in between 0 and 3, so 0 here, at 0, you see that it's open there. So meaning it will what? It will be open. So like that. And then at 3, it's closed in this one. And then 3 is also in this set here. So meaning it's going to be closed there. So at 3, it's going to be closed. So this here is my this answer which I'm looking for here. So I can then just write it here well. Say that A intersect B union C complement is just equal to 0, 3, and then I close. So writing this, drawing this, there is just, you have 0 and you have 3. And there it's open and there it's closed, like that. Okay, so this part here, these are the numbers that we are talking about. All right, so next. So next we have this here is just a complement set difference that is of B, C, and then the complement outside. So now here you distribute that complement. So let me distribute that complement. You're going to have that this is going to be equal to, this will give you A, then here, okay, so before we distribute, we can write this that is inside, we can write this as A complement, that there, we write intersection, and then B, this inside, we write intersection, C, so the complement goes there because we've removed this difference, so the complement goes there. And because here we removed the difference, we put intersection, so the complement to come here and then the complement outside. Okay, so now distribute that complement, you just get there A, and then by Demorgan's law, this flips from intersection to what? Union, and then just like that, there this complement goes because you're complementing there, so it will be B intersect C what? Complement, like that. So this is what you're going to what? To get. So can you erase this now? Okay, so this here, they're saying B intersect C what? Complement. C complement, again, we recall that C complement, like that, is just 10 to infinity. And then our B is this one here. Then where do they intersect? Well, you can see that easily using the same number line. So that would be the intersection here. We want B intersect C complement. So my B is 0. Let's say 0 is there. So 0 to 8. Let's say our 8 is there. Like that. It's going to be open there at what? At 8. So at 8 here, I'll open like that. And then my C now. What's my C complement? C complement, we say 10 there, open to infinity. So now where do these intersect? Here, there. Can I check any intersection? Are there any common parts between? So this part here is the B. This is the C complement. Do they intersect? No, they don't. The intersection is empty. So it means A union what? The empty set. So then this part A union the empty set, you're just going to get what? The set A. Now after getting the set A, that simplifies your work. It means you just have to plot what? The set A, because that's your what? That's your answer here. So just plot on this diagram here, we will plot set what? Set A. Set A is just, which we've been plotting, -7 to what? To 3, like that. So here open, there closed, and like that you would have plotted. So yeah, like that. That's your set A. All right, we do the last one here. We're going to get, okay, so this here is you have A complement, then intersect what? B complement. So what is this here? So A complement intersect B complement. By the Demorgan's laws, we can just write this as A union what? B, and then complement. A union B and then complement. So what is A union B? So A union B, we can, so here negative, like that. So our A is -7 to 3, like that. So there it is open. Okay, let me write that well. So 3 here, so there it is open, and there it is closed. That's my A. Then my B is just going to be 0 there, and then you have what? 8 there. So 0 here, open, and then 8 there. So union the two. So union the two now, if I do the union, that is A union what? Union B. This one, what is this going to give me? So that is just going to be, it's going to be open at what? At both ends. So it's going to be open at both ends. So I'm just going to have that this here is going to be from there open to the last point open, because I've brought them all together. That's the union. Now, what I'm interested in is the what? Complement. So that complement is going to be here. So if here it's open, meaning the complement is going to be closed, and it will go that way. Here it's open, so it's going to be closed, and it will go that way. So this here, my A union B complement, which is just the same as A complement intersect B complement by the Demorgan's laws. we know it's going to go from negative infinity all the way to negative 7, then I close, union, then there, 8, and then all the way to what? To infinity, like that. So that is what my set is going to be. And then here, out of this here, you can just, if I erase this part, so that there that has remained in green is the set that I have been, that I am looking for, or was told to look for, which I have found, and like that here. Okay. Let's do this one here. So this one says, let R be the universal set. So our R is still the universal set. And then they're telling us that A is equal to that and B is equal to that. Illustrate Demorgan's laws using sets A and B. So what are these Demorgan's laws again? So just a reminder, that is A. So if we say A complement intersect B complement, this here is equal to A union B complement. So this is the first form. And then you have the second form to be, if you say A complement union B complement, this is the same as A intersection B and then complement. So this here is the second form. Okay, so we have 1 and 2 there. So we must show these. So let's start with this part 1. So in short, we show that the left-hand side is equal to the right-hand side. So this here, left-hand side, then I'll be checking that, is it going to be equal to my right-hand side, which is there, like that. So I start with the A complement intersect what? B complement, like that. So now what is my A complement? So my A complement here, I know if that the, okay, let me just erase it here, then I write it a bit down. So we know that our universal set here we're talking of is R. So that's negative infinity to infinity, like that. So if it's that way, then we are just going to have that, if we say A complement, so our A being that there, our complement then is going to be, so on a Venn diagram, in case you can't see this, I mean on a number line, you're going to get that. So your A, plot your A first. So your A is going to be negative 7 and then 3 there. So it's open and then closed there. So your complement is going to be there, closed, and then goes this way, and there, open, and then it's going that way. So in short, this here is going to be negative infinity to what? Negative 7, closed, union. Then the other part is what? Open at 3, going all the way to what? To positive there. So that is what your A complement is going to be. Okay, next we find the B complement. So B complement, you're going to have, that is, we say our 0 is here, and then we have 8 there. So it's open here, it's open there. So complement will be there, closed, all the way there. There, closed, all the way there. So B complement is going to be equal to, so my B complement is then just going to be what? Equal to, so this here, that's from negative infinity to what? To 0, and it's closed at 0. Union, closed at 8, and then all the way to what? To infinity, and then there, like that. So this here is, those two sets are my A complement intersect B complement. So you just have to intersect those. So I'll write them here. I'll write big bracket, and then I say negative. So then I say small, then negative infinity, comma, negative 7, like that, union, and then 3 there, comma, infinity, like that. So, and then intersect, the other one is negative infinity, then 0, then what, comma, it's closed here, then union, and then closed 8, and then infinity, like that, and then you close. So this here is your left hand side. So let me just move my right hand side somewhere here, right hand side. Okay, so now this here is our left hand side. How then do we, what do we then move? So from here, you get the intersection of the two. So which we could see also on the same number line. So negative infinity, infinity there. So you have negative 7, and then you have 3 there, you have 0, and you have what? 8. So this one, for the first one, it's closed there, and then it's going that way. And then there you have, it's open there and it's going that way. And then the other one there you have, it's 0 there, it is closed at 0 and it's going that way. And then it is what? Closed at 8 and then it's going that way. So they're telling you what are the common parts now. So this part here, this is common. This part and that there, these are common. So what are these parts? So these parts are just going to be, you have from negative what? Infinity there to what? To 7 to negative 7, and it's closed there at 7. Then union there on the other side, that is, it's closed at 8 and then all the way to what? To infinity. So this is what we get on the what? Left hand side. Let us now see, are we going to get the same thing on the what? On the right hand side if we do the same. So on the right hand side, we start now, it will start with A union what? Union B. So we start with A union B. So my A union B there, or A union B what? Complement is what we have to get. But then we start with A union what? Union B. So my A is there and my B is there. So the union is going to be, so if you write that on a number line, you get negative infinity, you get infinity there. So that is going to be negative 7, you have 3 there, 0, and 8. So this here is going to be there. You have your A is open here, it goes there and it's closed. And then your B, it's open here and it's open there. So the union of these is just going to be negative what? 7, then negative 7, what else there? Negative 7, and then all the way to this 8 there, all the way to 8, and it will be open at what? At 8. Okay, so this is what you get as your A union B. So A union B, you get that. So now here, we are then going to just say A union B is giving us that. So now A union B, what do we want? We want the complement because it's A union B complement. And this here is going to be, it means that the complement of this here is everything outside here, but is in the what? In the universal set. If you draw your number line, you see you're just going to get, it will be from negative infinity to what? Negative 7. Since here 7 is in, so 7 is in A union B. So in the complement, you're just going to get that 7 will not be there. So it will be there, I mean, to be there in the complement. So it will be closed there and then like that. Then union, the other side, you're just going to get 8. And then what? You have what? You have up to infinity like that. So here you see that the left hand side is equal to the what? Right hand side. Hence what? Hence shown. Hence shown. Like that we would have shown. On the last point, just in case you missed it, I'm still going to draw it. It was negative, negative there. And then we said our A union B is negative 7, and then you have 8 there. So it's open there and open there. This here is our A union B. Complement will be everything outside like that. Since it's open there, here we'll close. It's open there, we'll close, and it will go that way, which is just what we found. Okay, so we do the same thing even for the next one. Okay, so for the next one, they're telling you that what? A union B complement. So A, this is left hand side. So you say A complement union B. So you have A and that there you have. So, okay, so A union, A complement union B complement. What is that going to be? So on the number line, negative infinity to infinity there. So A complement is going from negative infinity to what? Negative 7, and then it's closed there. And then the other side, that's 3. It's open at 3 to there. And then B complement is from 0, 0, and then it's closed here. So let me use a different color. It's closed here like that, and then going that way. And then you have from 8, so 8, like that, closed, and it's going that way. So this here blue, and that there in what, in green is what is the so this is B complement, the one in blue is C, is A complement. Now union means just bring everything together and form one set. So this here is going to be from negative infinity to infinity, and then you have there, you have, it's going to be 0. Since here 0 eats up that negative what, this part of the negative what, negative 7. So in short, all this part here will be in 1 point. So you get there to be closed, go all the way there. And then this whole part again is going to be there. So at 3, so 3, it's open, and then you go all the way. So this here is our union between the two sets, which is just from negative infinity to what? To 0, you close, and then union from 3 to what? To infinity, like that. So that's what you get. Okay, so that's what you get there. Okay, so that's what we get on our right hand side. Now, what do we get on the left hand side? So we plot A intersect what? B. So A intersect B. So here we want A intersect what? B. So A intersect B first. What is our A? Our A, that's negative 7 to what? To 3. So that is open there, and that is what? Closed there. So after that, and then here you have 0, and then you have what? 8 for your B. So that is open there, and that is open there. So now you find the intersection. Which parts are intersecting? This part and that part, like that. But then at 0 to be open, because 0 is not part of the set P. So you have that this here is just going to be equal to 0 there, comma all the numbers up to what? 3. But at 3 to be what? Closed there. So like that. So now this here is our what we found here is our A intersect B. But what we want is the complement. So we take the complement of this. The complement is going to be everything outside this, but is what? In the universal set. So this here is going to be from negative infinity to infinity. If we plot that, you get 0, there 3. So open and then close there. So everything outside here, but is in that universal set, to be closed here all the way to infinity, open there all the way to what? To infinity. So that would be negative what? Infinity all the way to what? To 0, like that. And then I close here. So no. And then, so here it's closed, and then I close the what? The other side here, it has to be closed, because at 0 here, we indicated that it's closed. Union, open at what? 3, and then all the way to what? To infinity, like that. So now from there, you can see already that that's what we found to be what? Our left-hand side. So then you conclude left-hand side is equal to what? Right-hand side. Hence, shown. Hence what? You have shown. You have used those Demorgan's law to illustrate this. Okay. Well, that was the last question for this tutorial that we had. But then I'd also like to just show you how to access the other solutions, those that are starting on SADS. So what you do is you go to your web browser, and just type in discrete learning. So you see discretelearning.com pops up there. And then you can here go click on there. So after you click there, you find this website here. And then if you do not have an account, you can make an account here. Just go for start learning, and then you will be able to. So if you're not enrolled, it won't lead you here, but it will lead you to a page where you want to subscribe and make an account. So make an account. After making an account, then you can enroll in any one of our courses. So we offer mathematics, chemistry, physics, biology there. So enroll in any. So if you click and then you enroll in there, to bring you a figure that you have to pay, and then for you to access what information. Then when you're enrolled, you just open there, you see mathematics. So you see general mathematics here, you go. Then after now there, you have topics. So there'll be topic lessons, the summarized notes, the tutorial sheets, and past papers there. So you can check out any of these information. It being a tutorial sheet, probably you find it here in the what? Tutorial sheet folder. It's in the tutorial sheet folder. When you find here, you just go which university where you belong to, UNZA. So you go UNZA there, and then from there, you'll find here, so Math 1100, you have videos, and you have what, written solutions like that. And then you search in here, so you can go video solutions. So when you go video solutions, you find what video solutions here that are there for the tutorial sheets. So you find a folder for Math 11 10 in there, and then you just click there and you find this video, and also other videos for the next tutorial sheets will be found there. Okay, so this has been Tutor Marius. If you are new, remember to subscribe, and we are gonna see you in the next one.